Alright, this time we're going to start with chapter 5, quadratic equations. In class 9 you have studied different types of polynomials. One type is a quadratic polynomials like 2x squared plus x plus 1 equals to 0, or I'm going to give you two examples here, x squared plus 3x plus 5 equals to 0. Now if you observe both these examples are in the form of ax squared plus bx plus c equals to 0. In general, an equation of the form ax squared plus bx plus c equals to 0, where a, b, c, this coefficient of x squared, x, and this constant term c, a, b, c, where a, b, c are real numbers, belongs to real number, and a is not equals to 0 is called a quadratic equation with the real coefficients in the variable x. Now, roots of the quadratic equation. Roots of the quadratic equations. When we say roots of the quadratic equations, it simply means the zero of the polynomial. And when we solve a quadratic equation, it is meant to find the roots of the quadratic equation ax squared plus bx plus c equals to 0. The zero of the polynomial are called the roots of the quadratic equation. And to solve a quadratic equation, there are two methods here. I'm going to write down the two methods. The first method is method of factorization. Method of factorization, which is also known as splitting the middle term, that you have studied in class 9 already, splitting the middle term. And secondly, by the method of completing the perfect square. This method is new to you, so we are going to derive the equation for solving the quadratic equation by the method of completing the perfect square. So this second method will derive it. So I'm going to write the equation like this: solution of a quadratic equation by the method of completing the perfect square. Alright. Considering the quadratic equation, the general quadratic equation, ax squared plus bx plus c equals to 0, where a is not equals to 0. Now we are going to rewrite the equation in such a way that the coefficient of x squared is a perfect square. So to make a as a perfect square, we need to multiply with another a, and the first perfect square number besides 1 is 4, so we're going to multiply with 4a. This equation, the quadratic equation, by 4a, both sides, left side and right side. Multiplying the given equation by 4a, we get now 4a into ax squared. 4a into a is a square, and this x square, plus 4a into bx is 4a bx, plus 4a into c is 4a c is equals to 0. 4a into 0 is 0. Then the first term of this quadratic equation, 4a square x square, these two are in the form of a square, a square x square, so we're going to express this 4 in terms of square. It is 2 square a square x square plus 4abx plus 4ac equals to 0. Then if you look at the first term, square, 2 square, a square, x square. Square can be taken as common, ax whole square. Now it is in the form of a square. And we are going to consider, remember, in this derivation we are going to consider this identity, a plus b whole square is equals to a square plus twice ab plus b square. Now we got a square here, and according to the formula, it is 2ab. 2 is from a plus b whole square, then into a value here is the first term, ax, 2ax square, so this is a square, so it will be 2ax is the value of a, so that means it is twice a. And looking at the original equation, it is 4abx. If you multiply this one, you have to get this one again, but in order to get this exactly this number, you need one more value, which is b. B is missing here, so we're going to write b. That means it is in the form of a square plus twice ab plus, according to the formula, it is b square. Since we take this b square out of nowhere, we are going to subtract it again, minus b square, then plus, according to the original equation, it is 4ac equals to 0. Then looking at the equation, it is a square plus twice ab plus b square. So if you resolve into the factor, it is in the form of a plus b whole square. A value here is 2ax plus b value here is b, so it is b, 2x plus b whole square. From here to here is the expression of 2ax plus b whole square, then minus b square remains here plus 4ac remains here as well, equals to 0. Then it is 2ax plus b whole square. Transfer this minus b square, it is plus b square. If you transfer this plus 4ac, it will be minus 4ac. Then 2ax plus b equals to, if you transfer this square, it is root over, and whenever you transfer square on the right side or the left side of the equation, remember just before the root there has to be plus or minus. Root over b square minus 4ac. Then 2ax, transfer this plus b on the right side. You can keep either at the back of this root over b square minus 4ac or just in front of. So we are going to keep it in front in this case. Plus b, if you transfer, it will be minus b. Then the sign here is plus minus root over b square minus 4ac. Then transfer the rest except this x. That means you have to transfer 2a on the right side of the equation and leave only x. It will be x equals to minus b plus minus root over b square minus 4ac divided by 2a. So this is how we find out the roots of the quadratic equation, x value. Or talking about the roots, there are two roots of the quadratic equation. And remember, roots of the quadratic equation simply means the zero of the polynomial. There can be two zeros of the polynomial. That is why there will be two roots here. So I'll just write here. Therefore, the two roots are alpha. Alpha and beta are the two roots of the quadratic equation. For alpha, you have to take plus, and for beta, you have to take minus here. So alpha value will be minus b plus root over b square minus 4ac divided by 2a, and for the second root beta, minus b. Since we already take plus, we are going to take minus, so it will be minus root over b square minus 4ac divided by 2a. So these are the two roots of the quadratic equations, alpha and beta.